Hello everyone, and thank you very much for watching this live event, lesson 6 from the Spring Reactive stream. And today we discuss important essential methods from the publishers Flux and Mono. So what we are going to do today is go back to web application. In the previous couple of lessons we somehow implemented an endpoint but didn't use the endpoint as just an endpoint. It was basically just to trigger some code and discuss the basic architecture of publisher, subscriber, subscription, and make sure that you understand what's behind the scenes. And now we are going to be back into a web application, so we won't register the subscriber anymore ourselves. You already know now what a subscriber is, and if you followed the previous lessons, you also know that in case of a route or endpoint in a Spring Reactive application, we have Spring Boot basically configuring the subscriber for us. What we are going to do now is focus on a bunch of methods that is essential for you to know on Flux. And because Flux and Mono are basically publishers and they are very similar, you already know that Mono is similar to a Flux with only one element. So Mono is 0 or 1 element, Flux is 0 or more elements. It's enough for us to go through some of the methods in Flux, since you will be able to use them in a similar way with Mono. So we don't have to lose time and duplicate our discussion. If you're watching the event live, don't forget that you have a live chat, so you can ask me questions in the live chat. If you are watching the event recorded, you know that you can follow me on LinkedIn, Twitter, or you can leave your comments in the comment section, and we are going to discuss them in next videos. I already opened here for you the documentation, the API documentation for Flux, where you will see that you have a lot of methods. Again, we won't go through all of them. I have already extracted a part that I consider to be the most essential of them. However, I will put this link in the video's description and in the comments of the video, because you will want to take a look yourself on what other methods you have here, maybe other overloadings of methods that we will discuss. And whenever you implement anything with Flux and Mono, you definitely need the documentation. So it's the best place where you can go and find out how you can implement something. It is only one thing that I'd like to show you on the documentation, and then I'm going to step into code, and I will create a project and I will show you which are the essential methods I consider. Mind that when we work with a publisher, a reactive publisher, we want to work in a reactive way, which means that you will literally have to implement everything in a functional way. One of the most common mistakes that I also see in case of Stream API, for example, but in that case, when you don't have a reactive application, when it's a non-reactive application, maybe it doesn't affect that much, but I see this kind of trying to take out the elements from the pipeline and then process them somewhere else. And that's something you need to avoid. And if in the case of the Stream API and optional, which I also discussed in other videos on this channel, it's only a problem of design, writing your code in a clean fashion. In case of a reactive API like Flux and Mono, it is also a problem of making your app less performant. Actually, I would say against the reactive approach. So it doesn't really make sense to use a reactive approach if you take out the elements from the pipeline and process them iteratively. So that's one of the most common mistakes, and that will also, you will also find this in books or articles or other tutorials, maybe from other sources, as being using blocking methods. Because what happens is that when you want to take an element out of the pipeline, you have to block the thread and make it wait until it can get that element, so it cannot work with it anymore in a reactive approach. And that's basically against how as I also said a bit earlier, against the practices of using reactive. So my first advice, and then I will step in the code and give you some more advices and show you how to work with the methods. Do avoid as much as possible anything that is blocking. So some of the methods are even named in such a way in which you can find out easily that they are blocking. Like if you take a look here on the documentation, block first, which is equivalent to wait until you have a first element, get that first element, and then do whatever you want to do with it. But not all of them, not necessarily all of them need to have the block in the name. So what I do recommend you is take a look wherever you see that a method returns something else than a publisher itself, which is either mono or flux. It means it's a blocking method, and it means you should avoid it. Now, in case of a Spring Reactive Web application, if I'm not wrong, because I don't do that, but if I'm not wrong, you will anyway get an exception if you try to use a blocking method on the thread of a route. So that has been made in such a way in which you are forced to avoid using blocking methods, but not necessarily about Spring Reactive, but in any kind of reactive application you'd implement using any kind of reactive specification or implementation, you need to be aware whenever you are using a blocking method, make sure that you know what you are doing. So in this case, for example, it makes no sense because it's against it's like making your reactive application non-reactive. Why do you use reactive anymore if you use blocking methods? So any kind of method where you see that the method returns not a publisher but the element itself. You see this one here as an example. Of course, you also see from the name that is a blocking, but even if it didn't have the block word in the method's name, you would still know that it's blocking because it doesn't return a publisher. So you can see this one, for example, here, this is a non-blocking method. And how do I know that? I know that because it doesn't return directly the value, it returns a mono of the value, which means that it returns a publisher. So a very good advice and easy to remember and understand is always use methods that return a publisher. Whenever you work with reactive, whatever you do, find a way to do it such in a way in which you put all the values and maintain them on the pipeline. Let's continue with some examples. So also question, can you please tell the equivalent of DoOn success for flux? So doesn't it have the same here? Sorry for being, but I do remember the DoOn methods should be equivalent. Do first, do finally, DoOn discard, DoOn complete if you want to do something whenever the complete events comes. We discussed about the complete events. DoOn error if you have an error, DoOn next if you want to do something for the next element, DoOn subscribe. We don't have a DoOn success, but you don't have a DoOn success because you might have multiple elements, so you have to decide what you want to do. You want to execute something for each value on the flux. If yes, then the method is DoOn next. So it should be somewhere here, DoOn next. Here it is. You see it's a non-blocking method because it returns a flux. If you want to do something immediately after the subscription, then you use the DoOn subscribe. If you want to do something after an error, you DoOn error. If you want to do something at the very end, you either do it on DoOn cancel if you want to have that action triggered by the cancel event, or DoOn complete, which happens at the very end of the flux. And in case these events subscribe, next, cancel, complete, and error are not clear for you, you can go back into the last couple of lessons, and that's where we discussed the architecture behind the scenes, and that's very important for you to know. So please don't try only to understand the code in a Spring Reactive application. Try to also understand what's behind the scenes. That's why I spent a couple of lessons before discussing this architecture, because this way you know exactly which these events are. So I hope that answered your question about the DoOn success. And now I'm going back to code, because what I like doing most is coding, of course, and you know that. And I'm going to create a new project. Let's call it Spring Reactive C6, because it's lesson number 6, E1, even though I don't think we will have more than one example for this lesson. And you know that I'm going to add the Spring Reactive Web dependency, which should be everything I need for my current example. So I will wait a bit for IntelliJ to index everything. I need to wait for it to download the dependencies and stuff like that. And then I'm going to create just an endpoint, but this time that endpoint will really return the flux. So I'm not going to, as in the past couple of lessons, just create a void endpoint. I want now to really have an endpoint that returns a flux, and I want to take maybe 10 of the methods, 10 of those, a lot of methods you've seen there, that are most relevant, and discuss them one by one with examples. So what I'm basically going to do, I think it's split my screen. I will have Chrome on the right side, I will have the IntelliJ on the left side, and then we will discuss with the example. We will see on the right side what is the result. So okay, very fast, very quick. So let's create a controller and demo controller. You know already that you can create routes as well. I have explained, I think it was the second lesson where I explained the difference between using controllers and using routes and handlers. So it won't affect anyhow what we are doing now. I will simply minimize the code in this case, make it more simpler with controllers, because it makes sense. So I will simply need to add a REST controller here. And then I will create a method that returns a flux. Let's for the moment make it a flux of string. And use the get mapping annotation to map this to say path demo and the HTTP method get. So you already know that you can create a flux using the just method, and we already discussed a few ways in which you can create a flux in the past couple of lessons. You know that you can have a flux created out of a stream, out of an array, out of a collection. You can use the just method to specify the values directly, which is something we very often use in examples and tutorials. And you can even use a sync to schedule events in an unlimited stream or limited or unlimited stream in the pipeline. So you need to know all these examples, and we have already discussed them in the past lessons. That's why now I will simply just create this flux using just and add some values, some string values that I will use for my demonstration. Of course, you already know if I now return the F1 here, you see that when we use Spring Reactive, when we create endpoints or routes, we directly return the publisher. And even though we know, and that's what we learned in the past couple of lessons, we know that you will basically need to have a subscriber. Whenever you implement endpoints, you don't use subscribers. So you don't use subscribers because you have Spring Boot attaching the subscriber for you. So that's why it's enough for us to just define the publisher, and Spring Boot will make sure that will attach the subscriber and will provide the events whenever a client requests those events. So that's where you don't have and you don't need to implement the full architecture, the full design that we discussed in the past couple of lessons, but that doesn't mean that it's not what we discussed. It doesn't mean that you don't have a subscriber, it's just that you don't see it. It's somebody else taking care of it. So let me actually just open a Chrome and put it on my right side of the window and say I'm putting this on the left side of the window like this, and I'm going to start the application. And of course you already know that what I will get now is simply events with the values from the flux, and then I will continue with using specific methods that I want to discuss with you today. We need to wait a bit for my IntelliJ to compile everything, and I also realized that if you want to have the events, don't forget that you need to add the produces here with the event media type. So media type text event stream value in case you want them as events, and we just call the demo endpoint, and you see it's not coming as events because I didn't restart the application. So if I want to see them as events, I should have first added the produces. So let's give it another try to make sure we have everything in place. I will restart the application, and when I call again, you will see the events instead of the raw data the way it's coming here. So a couple of seconds and my app should start. Perfect. And now if I'm calling it again, these are the events. So you see, you recognize the events because they come with the data in front, and in each event it's basically one of the strings. Good. The first thing that I want to mention is that maybe some of the most important of the methods you already know. Even if you never used Flux before, and maybe even if you never implemented a reactive application, you might already know many of the methods that Flux gives you, and that's because many of them are very similar to what you use in Stream APIs. So for example, and let's take maybe the simplest of them, filter. So if you've ever used Stream API, you know that filter takes a predicate as a parameter and allows, going further, only the values that fulfill the request of that predicate, so for whom the predicate returns true. What I'm going to do is I'm going to show you 2 or 3 such methods, but I'm not going to detail all of them. I consider them fundamentals from Stream API, so in case you don't know them, which you should, because Stream's API is here since Java 8, which is many years ago. But if you don't, then my recommendation is go first into the Java Fundamentals playlist and make sure you know very well what's in there before trying to understand Reactive, because it will be much more challenging for you to understand Reactive if you don't know the fundamentals, the Java fundamentals yet, and the Spring fundamentals. So that's why I'm going to be quick with these methods, because I just compare them to what you already know theoretically from Stream's API. So for example, if I say the length of the method needs to be even, then what I expect is that, and that's everything I need to say, filter returns a flux of string that contains only the values that fulfill the predicate I gave here, which means that I should now see only the values that are odd in length. When I restart the application and I recall the endpoint, you will see only strings with even values coming. Okay. And definitely now we see BB is the only one that has an even number. This is 3, this is 1, and this is 5. All the others are odd, so since they are odd in length, you don't see them because they don't go through the predicate. How is the connection manager in a reactive API? In a non-reactive connection between client and server stays open until the request is processed. How does it work when we are sending the events? It's basically working the same, and what I recommend you is review the first lesson of the stream. You will see that in that lesson we have even went into the networking tab, and we have seen how the connection stays open until each element is consumed. So I'm not going to show that again now because it spends time, but you can anytime go back to the first lesson and review it. If this is the first time you see this series of lessons, we now discuss lesson 6, so you might want to go back and view the first 5 and understand them before starting with this lesson, because you will probably find the things we discuss less challenging to understand. So yes, we can see the same you can do, for example, if you use map, if you use distinct. But before going into map and distinct, for which are again the same that you already know from Stream API, I want to show you a very important, an essential method that you will find very useful when debugging your Flux and Mono implementation, and that's the log method. You have seen the log method. I know I used it a couple of times in the previous lessons, but now it's time to use it even more and understand it better. So the log method, which you can even configure to get a specific logger as a parameter in case you, for example, want to log some events of specific severity and so on and so forth. You will see that you have even the possibility to customize the logs that you send. In any tutorial, log with no parameters is enough, but in a real world scenario you might need to specify the logger. It's a method that you will find very useful, because whenever you put it there on the stream, it will collect and it will log in the logger defined by you, or the default one in case of no parameters, all the events, and that makes it very comfortable for you to see that what you are doing is right. So let me show you, for example, with this filter, which is pretty simple to understand hopefully, how can we use the log method to understand what happens. We will see what events happen before the filter, and then we will move it after the filter, and you will see how the log looks like and what can we understand. Again, I restarted the application to take the changes, but again, it's mandatory that you have seen or at least know the things we discussed in the previous couple of lessons about the basic designs in Reactive. Otherwise, you won't, or you will find it more difficult to understand what these events are. So I added this log method, and then what I'm going to do here is, of course, calling again the endpoint. And now what I'm going to do here is see the events. So you see that all the events that happened have been logged. So on the right, you will see the name of the event and the value. So you see that something subscribed to my Flux, which proves what I was telling you earlier, that even though you don't see any subscriber here, because we directly return from the method the publisher, there is still a subscriber there, but it's not us, but Spring Boot taking care of creating and subscribing it. So that's why you see an unsubscribe event. Of course, everything ends with an onComplete, and then you will see something interesting, and I always get questions about this when discussing in class the events, is that only one event has been requested here, but then we see 2 events actually happening, and then we have 31 requests, and then we see the next 2 events, and then we see the onComplete. And what I'm usually asked here is why does the subscriber request only one event but two of them are provided? This is something that you will see it's pretty logical, but sometimes creates confusion, especially when you begin with learning reactive. I want to remind you first that this request is something specific to a reactive implementation, and it's providing what we call back pressure. Remember that in case of any reactive app, the subscriber has to request how many events they want, and then needs to request again after receiving them, needs to request again if the stream didn't complete. So that creates what we call back pressure. I talked about it more in detail in the previous couple of lessons. So it's basically also what makes Flux different from Stream API. In case of Flux, you have a push model where the subscriber requests how many values they need, and then the publisher pushes exactly that number of values to the subscriber. That creates back pressure, which means that the subscriber is the one responsible to request as many or as less values events that they can process. So it's no longer the responsibility of the publisher if more values have been provided to the subscriber than the subscriber could have processed. It's the subscriber's responsibility to only request what they can work with. So that's why we have these events. So that's one of the things you already knew theoretically from the past couple of lessons, because that's what we did there. We went through the design of a reactive application, and that this back pressure is basically one of the most important characteristics of the reactive application. But then the question is, why the heck do I request one and I get two? Well, that happens because this log might be misleading, but it's about one event that really reached the subscriber. Let's think a bit about it. Did actually both these events reach the subscriber? The answer is no. Why didn't both of them reach the subscriber? Because AAA has an odd number of characters, which means that this value, which is the first one in the publisher here, didn't pass the predicate in the filter. So basically it is indeed that the publisher only provided one value, because only BB has actually reached the subscriber. So this one here, it doesn't refer to how many events went from the publisher. So it's not how many events the publisher provided, it's how many events the subscriber got, which means how many events reached the subscriber, which in our case is BB, which happens here to be the only value anyway in the stream with an even a number of characters, so the only one that we'll get in the end. Now a second question that I usually get is why 31, why 1 here and why then 31 here? Because this is the way the subscriber is implemented from the reactive Spring reactive application. So it's made, it's a smart approach. It's made in such a way in which it requests basically more values because it sees that it could process more. So it knows that it can at the next event get more values at the same time, and it doesn't need to take one by one the values. So the subscriber that Spring Boot configures behind the scenes is smart enough to make use of the back pressure characteristic of the reactive application. So that's why the first time only one event has been requested, but then many more events have been requested later. Of course, at the very end, it's clear that we will get the onComplete. You already know that the onComplete event happens whenever there are no more values in the stream. You can either have an onComplete at the end, an onCancel, or on error. Good, so I hope this is clear now. So now you see all this. let's see what happens and how does this look like when I'm moving the log method at the end. So I just moved the position of the log method. I do recommend you not to use the log method multiple times in the pipeline. Not that you can't do that, you can do that, but at least for me it was never comfortable to use it this way. I often got confused if I use the log method more than once. So what I usually do when I investigate something, I do place the log method exactly where I need in between those operations. You might have here more than one operation on the pipeline. Of course, we started with filter, but you will learn in the next minutes that there are a lot more things that you can do. And I usually, what I do when I investigate a problem, I do use the log method only once, and I'm going through the values that have been received, because what the log method helps me is always see the values that have been provided exactly after the publisher that is returned basically from the operation after which you put the log. So in this case we have seen all the events, but when you put the log here after filter, you will actually see only the events that are coming out of the filter. So you will only see the events in the publisher returned by filter. So that's why you see a lot less events here, and actually you only see one of them. You only see BB because this is the only event that's fulfilling the predicate that filter method declares here as a parameter. So that's basically what you get with the log. You get all the events, and it's very useful because you get all the events exactly on the publisher that is before you call the log method. So it's a very important method to remember, because it's one that you will use. I expect you will use very often to debug your application, find out why maybe something is not working the way you expect it to work. You can just go with the log method one by one through the operations and see where it's something happening that you don't expect. Maybe I didn't expect only BB to be here, and when I see this, I can go up and try to understand why I only see this event. Cool, you already got it. So let's see what other things can we do. So let me actually put also log as well here and comment it out, so that you will remain with all the things that we discussed when maybe you will want to get this from my GitHub account afterwards. You have other methods as well. So for example, distinct. Distinct will help you, same as in the case of Stream API, eliminate duplicates. So if you use distinct, you will basically eliminate all the duplicates in the stream. So if I have a 3 times here, and it will rely, of course, it will rely here on the comparable of the string class. But if you will look, you will see that you have multiple distinct, so you can specify what distinct means in case you want to do that by using an additional parameter. Let's focus on just using distinct and prove that distinct indeed eliminates the duplicates from the publisher. So I'm again restarting, and then I will call the endpoint, and that's what you will do. Let me actually make this a little bit smaller maybe, and make this a little bit larger so we can see better the code. Okay, so you see that AAA appears only once, even though I put it 3 times here. Now you also have a method that is called distinct until changed, and you might have wondered why I added 2 of the duplicates at the beginning and then only 1 at the end. Because in the case of distinct, the one that I just used here, you see that it eliminates the duplicates from the whole stream of events. But you might want to only eliminate the duplicates that are one after the other. So if you want to do that, for example, Flux provides you a method that is called distinct until changed. Distinct until changed will only eliminate this element here, but will keep this one and this one, so will not completely eliminate all the duplicates. Okay, how would you compare the number of requests being handled between reactive and non-reactive implementations? In a non-reactive, it uses a thread per request model, which is higher in number. Yes, something that we have probably discussed also in the first lessons, so in the first 5 lessons, is that in a reactive application, we don't have one thread per request. But I don't necessarily understand your question. What does it mean? How would you compare the number of requests? Well, in the Netty implementation that we use here, which is a web server with a reactive implementation, if you are using a profiler, you will see basically that Netty provides at the very beginning a bunch of threads that will take the events, and still Netty is able to horizontally scale the number of threads in case that's needed, or quit the threads that are not needed. Now, I'm not going into the Netty implementation because it's not the purpose of my stream, and is maybe rather essential only if you are configuring Netty, which is not the case for a usual developer, or in case you are debugging something. But as an idea, what happens behind the scenes is that you have a number of threads, they are taking some events, and Netty takes care of making sure it always have enough threads to take all of the events when the number of the events gets higher. So I hope that answers your question. How do you learn new technologies? Reading books, trying the code myself, watching tutorials like I'm trying to do here, reading articles, being part of communities. Okay, let's go back to our reactive, because otherwise we will not have time for everything. So I was basically restarting this. I'm going to call it again, and you see indeed that my distinct until changed only eliminated the duplicates wherever they came one after the other, but not all the duplicates in the stream. So you see that A doesn't appear 3 times, it only appears a couple of times, because for this one the duplicate has been eliminated. A very important method is the map. You already know that map is available also in the Streams API, and you know that map takes a function as a parameter, and its purpose is changing from one value to another. So mapping actually from, in our case, the string to another value, which can be of the same type or can be of another type. So let's just take as an example, you can use the length method here to change the value from string to integer. Of course, if you do that, then the method signature has to change as well, because the lengths are integers, and you have to provide the correct return type. You will return here, you will transform your flux of strings into flux of integers. So that's why we need to change the type in that case as well. But of course, what I did here is only mapping the value from one type to something else, string to the number of characters in the string in this case. Okay, and we can see it. And we also have, and that's very important, a flat map. And a flat map, which you hopefully also know from the Streams API, allows you to change, to extract somehow values and put them on the stream itself, in our case on the flux. So maybe in this case an example would be what if I want to change my flux of strings into a flux of characters? So it's like an explode of the value. You transform the value itself in multiple values on the same stream, in our case on the same flux. So can we do something like this? Can we change the stream, the flux of AAA and strings into a flux of individual characters? Or if you have a flux of lists, can you split the flux of lists into flux of the elements in the list? Anything that means splitting a value into multiple values on the same stream, same as in the Streams API, can be implemented with flat maps. So for example, in this case, you will need to have a flux of how do I do that? Create, I think is the, no, I don't need the seeing from just so maybe it works with just, but I'm not sure. Anyway, let's try it. So I have an S, and then I say, for example, split after nothing. Let's see what happens if I use just, and then flux of object. It's actually flux of string should be here, of course, because now each character will be a string. I think it should work with this way. Otherwise we use from array or something like this. So let's see. So you understand what this happens here. Each element on the initial stream is changed into a flux that will afterwards be merged. So yeah, indeed, we end up with a flux of events for which event having an character, one of the characters from the initial stream. So instead of having the words, I have 1, 2, 3, 4, 5, 6 A's, and then 2 B's, and then 1 C, D, 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 and then A. So I changed the flux of strings into flux of characters in the string. Same as flat map can be used for streams. So filter, distinct, map, flat map. All the DoOn's methods, you asked me about them. So the DoOn something methods, I'm just going to use one of them, but if you just write DoOn or take a look in the documentation that I was showing you at the beginning of the video, you will see that you have plenty of them. So I have DoOn next element, so for each element, DoOn the cancellation, DoOn complete, DoOn when one element is discarded for any reason for the stream, DoOn any error that happens. I think we even used some of this in the previous lessons. DoOn the subscription. Whenever you have an event that you want to trigger, you can use one of these methods here. So if I want to do something for each element, I can do that by using DoOn next, and then I say DoOn next system out print line. Of course, you don't have to print it in the console. In a real world application, you might want to do something else with that value. So you just take the value and you can do whatever you want. So in my case, I will basically see for every element the value printed in the console. Let's wait a bit to have it running. So what you don't want to do, and yeah, you can see the result here. So the elements have been printed. You see that the DoOn methods, they do return a publisher, which means that they are indeed non-blocking. What you should never do is do something like I'll define a string here, list here, sorry, which is empty, and then say something like list add, and then return the list. So this is something that you should never do either with Stream API and especially not with reactive. Okay, so and do something. I've seen these kinds of implementations, people not knowing how to work with the reactive implementation, how to address something. They were putting it in a list. So somebody asked me, okay, if I want to get a list, what do I do? And then they found this workaround in which you define a list, and then for each element you put it in the list, and then you return the list. And this is something you shouldn't do in a reactive application. Why? Because you simply changed the reactive approach to a non-reactive approach, which then raises the question, why do you use a reactive application anymore in this case? Then make it non-reactive if you don't need a reactive approach. So never do something like this in a reactive way. Anyway, in this case, it's not even working because the flux is not, you are not granted that you will get the values before reaching the list. So then I see even a bigger mistake is putting some kind of a waiting here, a blocking here with a sleep or something. Never do something like this. So this is not an approach, a reactive approach. If you wanted to have a list in the end on the stream in a reactive application, what you can do is using a collector. So for example, what you could have done is still returning a publisher, but instead of the DoOn next, okay, let me just put it like this and comment it out. Sorry. You could have used a collector, so you can say something like collect collectors to list. But when you do something like this, then what you return here actually is a flux, is a mono actually. It's a mono of the list. So it should be something like this. So you see, when you want to say get a list out of the values on a pipeline, never do something like try to change the reactive into non-reactive using kind of workarounds. Always, and remember my advice from the beginning of the lesson, always use approaches where you return a publisher. It can be a mono or a flux, but always return a publisher. And with this in mind, we also went to the next method, which is the collect method. And you see that you can basically use the same collectors that you are used to from Streams API. And they are implemented for Flux such in a way in which the logic in the collector can be used to put the value as a publisher itself. So that's basically now working, and it's the way it should work. So in my case, the logic here collects the values from the flux f1 into a list and then returns the list as only one value provided by the publisher, by a publisher of type mono. Mono being again same as flux, but with only one value maximum. So you see here you only have one event containing the whole list. So if that's what you wanted to do, this is the right way to do it in a reactive application. So don't try to find workarounds. Now I'm not sure if it makes sense to say that you can use any kind of collector. So let me show you only one more, but then I rely on you learning Streams API, because if you learn Streams API from Java 8, we have them, so for a long time ago, you will know how to use all this. You can basically do anything here, like even I know summing int, say, or averaging int, or whatever you want. Say we want to sum the length of the strings, then that should turn into a mono of integer, I guess. Okay, makes sense. And then basically this approach will return a mono containing the sum of the lengths of all the strings here. So you see how easy it's just understanding a functional approach if you already have experience with Stream API, a quarter of the methods on Flux are the same, and they are used in the same way. So if you understood how to use them there, then you will know how to use them with Flux and Mono as well. You don't have to learn something new. Then you have the events as well that we discussed, and then you have different methods that you can use, for example, to merge streams. Let me show you, merge fluxes. Let me show you some of them. So again, we've seen filter, log distinct, map, we've seen the events, we've seen flat map. You understood that you can use collectors as well. One thing that that people do sometimes is trying or needing to merge some of the streams. So for example here, what if I have two fluxes? Maybe I get them from calling some endpoints, or maybe from two different databases, or maybe from two tables in the database. Is there a way in which we can merge them into only one? So let's say for the simplicity, this one will only contain a small lowercase. Okay, so can we get from F1 and F2 only one publisher with all the events? And the answer is yes. You can basically do concat with, there are two main ways. I prefer the concat with. There is also the concat method, which is a static one in the Flux. So you can say flux concat and give multiple publishers, or you can use the concat with. For me, the concat with is easier to understand because I see it as a normal operation on the stream. I do prefer to avoid using static methods if I can. And then I can say concatenate F1 with F2. And that will result, of course, in a flux of strings that will contain all the values. So this will literally concatenate these events with these events into only one publisher. It will give us a publisher that will be a result of containing all the events from both publishers. So if I'm returning this and restart the application, in the browser, I will see all the values with uppercase as well as the ones with lowercase. So you see all of them. And do avoid making a confusion with, I think usually people make a confusion between the concat with and then many, which sounds very similar, like concat with, it's a concatenation of values. But when you say then many, the trick is that then many will only put the values from F2 on the result. So you say F1 then many F2. If I'm simply restarting now the app and calling the endpoint, you will only see the lowercase in the browser. And then when I show this, people usually ask me, well, does it make any sense? Why would you need something like that? I mean, in that case, wouldn't I directly simply returning F2? Well, no, it's not the same thing, because if you might want to do something like DoOn next, and DoOn next something with the values from F1. So this is what I'm printing here. This S here is the uppercase. And then further, I'm working with the lowercase values, and then again I can apply any other operations. It's not necessarily directly returning them. I can apply any other operations, do whatever I want. So what you will see here is that in the console, the uppercase values will appear, while in the browser, the lowercase values will appear. So that's what happens with then many. Then many means I do something with a flux, and then I stop with that one, and I take another one on the same operation, and I maybe do something else with that one. Like in my case here, I'm printing in the console the values from the publisher F1, and then I return and send to the client the values that are provided by publisher F2. So don't confuse the concat with then many. They are not the same thing. Concat is literally concatenating the values into only one flux. Then many allows you to do something with a publisher. Then on the same pipeline use another publisher and use another publisher, and you can do as many as you want there. Okay. And also a confusion usually is made between then many, concat with, and zip. The zip methods like zip with or flux zip, which is a static method, and it does the same thing. When you use the zip method, you do provide also a function to concatenate the values. So what zip with does, it takes a value from one stream, from one flux, and takes one value from the other one, and then does something with those and transforms them into only one value. So in my case here, I can say F1 zip with F2, and then I have to say what happens. It's X, Y, for example, and let's say I do simply concatenate them with whatever, an equal sign in between. And if, and you see it's not the case here, but if the two fluxes have the same number of values, then of course that will be the number of values that will result in the end. But if the fluxes, like in my case, if either one of them has a smaller number of values, like in my case here, you will only get those values. So in my case, what will happen is that because F2 has only 3 values, it doesn't matter that F1 has 6. Here I will get an AAA equal quert, AAA equal quaz, BB equal SSS, and then these values here will be lost. So did I restart? No, I didn't. So let me restart the application and then explain it on the result. Maybe it's even easier to understand when we see that. And then of course when you call the method, as I was telling you, so you see it takes a value from the first, and then it takes the value from the other one, and it does with them whatever you told it to do here. So in my case here, it concatenates the first one with the equal sign and with Y. So that's why the event value looks like this. It's AAA equal this one, then again AAA equal this one, BB equal this one, and then the other ones have been lost. And it's important to remember this the operation stopped completely. So we can prove that if we are going here and say log, you will see that the operation stopped, so the values have been lost. If I'm going to log, you will see that we have the complete event in the end, so it doesn't still wait to get values. It literally considers it as being a completed stream. So when I'm doing that, you will see the events with log. I see the subscribe. You will see the values, so the 3 values, and then the on complete, just because there are no more values here. The stream has been considered completely completed. So that's it. What you can do with this method. So of course I've shown you only a small number, but remember what I've told you. So I didn't go into all of them just because I'm pretty sure you know already many of them. It doesn't make sense to go through all of the methods from the Streams API, because I consider them fundamentals, and if you don't know them already, they are already explained, and you find them in the Java Fundamentals stream on this same channel. Same with the collectors, which are part of the Streams API. I expect you know all the essential collectors. They are even requested for the OCP exam. You simply use them the same way, so I just gave them as an example here so you know they exist. Now I rely on you knowing them from the Java fundamentals. Same with distinct, map. Then we went through a few methods which are specific to the publishers on reactive applications, like the event methods. We discussed about the many, zip, with and concatenation, which are very often used in implementing the business case. And we discussed also a few anti-patterns and what you shouldn't do. Remember, never try to return something that is not a publisher in a reactive application, and never use a blocking method. So do avoid the blocking methods. Now, again, my advice further is, and I will put a link into the comment section and the description of the video, go into the documentation, and you will basically see that the documentation it's very nice. When you click on any of the methods, they are explained pretty well. So for example, mono, this all method returning a mono of boolean, if you work with Streams API, you might already understand what it does. It just returns you a mono of true in case all the values fulfill a specific predicate, or false in case at least one of the values doesn't. But if you don't know, you just click on it, and then you will see that most of the methods have a nice diagram that help you understand very easily what happens behind the scenes. So if you want, maybe I should explain a bit how this diagram should be understood. So maybe it's if you see it for the first time, it looks complicated, but it's not. Just imagine this is a timeline. The circles, squares, stars, whatever you see here, they are events. The only thing I dislike about these visuals, honestly, is that they used colors. Colors are good, but you will see that sometimes they use color in a way in which if you don't see the color, it's difficult to understand the visual, which is something I don't like, because it's not helpful for people who have problems with their eyes, like they are color blinded. So hopefully you are not. I'm not color blinded, but I do prefer, for example, when using visuals in my presentations or books or courses, to avoid situations where people need to see the color. So hopefully this will not disturb you, but otherwise the diagram is easy to understand. All of these diagrams are very easy to understand. These are the events on the timeline. You read the timeline passing from left to right, so the time going from left to right. It says here all of the figures, all of the events coming are circles. So if only circles are coming, then the result will be true. If at least one of them is not, then the result will be false. So exactly what I was saying is a visualization of saying if all of them fulfill the predicate, then the result is true. If if at least one of them doesn't fulfill the predicate, then the result is false. So I just explained you this diagram, so you know now. You can go through any of the diagrams in the documentation, and you will literally understand what happens. Any of the methods will provide you a nice diagram, a nice visual that you can use to understand easier how that method behaves. Cool. The time has been spent for our video, and I think I have anyway went through everything that I wanted to go through, and if everything was hopefully clear for you, I expect you now with a little bit of exercise, because of course without an exercise you will not become an expert on using flux and mono, but with a little bit of an exercise which in my advice would be just take and implement, as I've done in this video, a few examples and try the methods that I've shown you, and maybe take some other methods from here, like the ones maybe I didn't show you, like all, any. They are methods that are very similar with the ones from the Stream API. You will definitely in a very short time be experts in using Flux. So with that being said, thank you very much everyone for attending the live event and for all your questions and comments. I hope I was helpful, and I hope the content is and will be helpful for you. And let's meet together next time to continue our discussion on reactive applications and Spring Reactive. Thank you very much everyone for watching the event. Have an excellent time for learning further, and waving goodbye. Cheers.